experiment is to separate an unknown dye into its components using paper and microcolumn chromatography. The retention factor, RF, is a ratio between the distance traveled by the dye and the distance traveled by the mobile phase. The distance traveled is determined by the attraction between the dye in the stationary phase and the mobile phase. In this experiment, the higher the polarity of the solvent, the higher the RF.
To prepare a TLC plate, mark a line 1 cm from the bottom of the plate. Use a capillary tube to spot the dyes. While you are doing this, have another team member prepare beakers with a small amount of the solvents and plastic wrap to reach equilibrium. Place the TLC plate inside the beaker and watch the movement. Prepare a microcolumn by first placing a small plug of glass wool into a pasteur pipette, then add sand. Add silica gel almost to the top and the solvent that gave the best separation in the initial experiment. Add 2 drops of the unknown sample and sand. Add solvent and push through with the bulb. Be careful not to suck everything in or you'll need to start over. Continue adding solvent and collect the different colored solutions in small beakers. You will later transfer these to a cuvette and scan at all wavelengths using a spectrophotometer.
Microcolumn chromatography is similar to TLC chromatography in that it depends on the polarity of the constituents, but the dyes it produces will be in the opposite order because the solvent is added from the top. Also, TLC will likely produce a better separation.